Okay, you guys, let's go to the rules for this packet. Yes, it's on page 2 of your packet today. Now, rule number 1, you guys have seen what an exponent is. An exponent has a base, and the exponent part is the number that's to the top and to the right of the base. Still looks a little fuzzy to me. There we go. So, in this case, we have the base A with an exponent of m and another base A with an exponent of n. What operation is going on here with these two? What operation do I have? No, it's multiplying. Okay. Now, this is the rule. If you are multiplying the same base, you're multiplying the same base. So in this case, it's A and A. Then you can take that base, and it's the same as adding the two exponents. Now let me give you an actual numerical example. If I have 2 to the second power, and I'm going to multiply that by 2 to the first power, all I need to do is take the same base of 2 and add the exponents. What would that be? What's 3 plus, I'm sorry, I'm giving you the answer. Okay? Now, is that really true? How much is 2 to the second power?
4.
How much is 2 to the first power?
2. Oh, wait, 1.
No, it'd be 2. It'd be 2. So what's 4 times 2?
8.
Now, isn't 2 times 2 times 2
8.
also 8?
Yes.
Okay? So that's true. As long as your base is the same base, and you are multiplying different exponents to that base, you can add the exponents and you get the same answer. Now, if I'm going to be adding when I'm multiplying the same base, what do you think is going to happen when I'm dividing?
Subtraction.
You're going to subtract. So that's the next rule. The next rule says, if you are dividing something that looks like a fraction here, it can look like a fraction or it could be written horizontally. You're going to take the top number and subtract the bottom number when it comes to the exponents. So if I had 3 to the second power divided by 3 to the first power, my rule is telling me that I would take 3, and with my powers here, with my exponents, I would go 2 minus 1, which would give me 3 to the first power, which is just plain old 3. Now let's see if that's true. We'll come over here and actually test it out. What is 3 to the second power? That means 3 times 3,
9.
right? And what is 3 to the first power?
3.
3. So I can write this as 9 over 3 is equal to 3. Is it not? Those two are the same. So this would be true. As long as the base is the same, and I am dividing two bases that are the same, I will get the same answer if I subtract the exponents. The top exponent minus the bottom exponent will give me the same answer. So are there any questions on the product rule or the quotient rule? Multiplying or dividing? No questions? Okay. All right, now rule number 3 says power to power. If I am going to take a power and raise it to another power, that's the same as multiplying the exponents. That's what this means. So if I have 2 to the second power, and I'm taking the entire power and raising it to maybe 3 here, that's the same as taking 2 to the second times 2 to the second times 2 to the second, which would be 2 to the what? 6. Well, isn't that the same as taking 2 to the 2 times 3, which is 6? And then if they want you to evaluate it to a standard form, you would just go 2 times 2 times 2 times 2. Basically 8 times 8, which is 64. So you have to look at the question. Do they just want you to write it in exponential form, or do they want you to actually write it in standard form? Any questions about taking a power to a power itself, using that as a base? You actually multiply them. Question, Curtis?
Like that,
Yeah.
The x to the 5th power with parentheses and the 3 on the outside of it. That's what they're asking you to do then, and that's
Yeah. See how they had x to the 5th power. They're raising this power to 3.
Okay.
So that's like having x to the 5th times x to the 5th times x to the 5th,
Gotcha.
which is x to the 15. You just multiply them. Okay? So that is the power to power. Then we have a product to power. Okay? So if I have more than one variable in here, or more than one base, let me give you an example. Let's have 2 different bases here. If we have the base of 2 to the 3rd power times the base of 4 to the 1st power, and then I'm going to raise this whole thing to 2, that's the same as taking 2 times this 3. How much is that going to be?
2 times 3 is 6.
So it'll be 2 to the 6th power.
Oh.
And then 4 to the 1st power, what's 1 times 2? So it'll be 4 to the 2nd power. That's what they're saying, is if you have more than one base, and that's inside of parentheses, and you're taking the entire thing to a power, each one of those bases, you have to apply the rule of multiplying that power number to the original exponent on the base. So in this case, if I had 2 to the 3rd power, and I'm taking the whole thing to 2, I have to say 3 times 2, which is 6. And then I do 4. 4 to the 1st power times 1 is going to be 2. And when I evaluate all this, we have 64 times 16. You guys can do that if you want. You get that same standard number as if I went 8 times 4, which is 32, and then took 32 times 32, which is the power. They'll be the same answer. What is that, by the way? Did somebody do it?
1,024.
On both sides?
Yeah.
Okay. So it works out. Now, sometimes you have a fraction inside of a power. And that's this rule number 5, where you're taking the quotient to a power. So what's one of our favorite fractions? Let's say 2 to 5. And 2 to the 5th. Up here, the 2 is to the 3rd. Up here, on the bottom, it's to the 2nd. That entire fraction with the 2 different bases is going to be taken to the 2nd power. I just want to do some lower numbers so we can easily calculate them. What does it say that we need to do? we're going to do exactly the same thing that we did up above, except for at the end we reduce if we can, or divide if we can. Now, since 2 and 5 are both prime, we're probably not going to be reducing anything. So this is the same as saying, okay, I've got 2 to the 6th power over 5 to the 4th power. Because what you do up here on the top, you got to do to the bottom. Don't forget the bottom, which a lot of people forget. This will give me 64, right?
Yep.
And then 5 will be 25 times 25. 625?
625?
Yeah, that's what I got.
64 which is 25.
And we can't reduce anything.
No.
Okay? So even if I just did 8 over 25, and then I square that, I would still get 64 over 625. Rule number 6 is the zero exponent. You guys should know this. Anything to the 0 power is 1, because if I have 9 over 9, what does that equal to?
1.
Now 9 over 9 is the same as taking 9 to the 1st power divided by 9 to the 1st power. Well, that's the same as 9 to the 1 minus 1, which is equal to 9 to the 0. So anytime you have anything to the 0 power other than a base of 0, you're going to get 1. This is not true for a base of 0. If you have a base of 0, why are you even doing it? So I have this entire power here, along with an 8 coefficient. All of this is in parentheses to the 1st power. What this means is 8 to the x over 4 divided by 8 to the x over 4. How much is that? 1. Anything over itself is equal to 1, and even if you have a variable and a coefficient. So when you see something to the 0 power, that means it's that number on top divided by the exact same number, and that's why you get 1. And the only time you wouldn't get 1 is if you had 0, the whole number 0, over the whole number 0. You would get 0. So this is not true for a base of 0. And then negative exponents. Now I'm going to give you the rule for negative exponents, but later on in your packet, you guys are going to have a lot more practice with the negative exponents itself. When they say negative exponents, this is what they mean. Let me get a little blank piece of paper here. If I have 2 to the negative 3, two to the negative 3 is the same as saying, okay, I have 1 over 2 to the 3rd. I am going to do what's called the inverse. Remember when we did dividing fractions, we flipped them around? Well, that's the inverse. That's all that is. You take the inverse with the same power. If I had 7 to the negative 2 over 4 to the negative 3, these guys are switching places because their exponents are negative. That means inverse to inverse. So this is going to become 4 over 3, and this is going to become 7 over 2. You take the inverse, you flip it. So anytime you have a negative exponent, you're going to flip. You might even come across a situation where you're multiplying. Let's say you have 8 to the 4th power times 8 to the 2nd power. I'm sorry, let's make it negative 2 power. Now, what was it we were supposed to do if the base is the same? What's the product rule? I write down the base, and then I'm supposed to do what?
Add the exponent.
So if I take 4 plus a negative 2, you guys know how to handle negative numbers. What does that become? A to the what? If I have a positive 4 and a negative 2, that becomes what?
That should be a negative. That should be a positive.
Positive what?
Positive.
Positive what?
Two.
What?
Two.
2.
Yeah, because I have 4, and then I'm taking away 2. So I'm going to have 2. And it's going to be positive. All right? Now, if I had, we did a negative situation, negative and negative, but wonder if I had like a base of 3 to the negative 7 divided by 4. I'm sorry, let me make it 3 to the 4th. Okay? Now, when I'm dividing the same base, what's the rule? That was rule number 2. What am I supposed to do?
Subtract the exponents.
Subtract the exponent. So I'm going to write the base of 3, 7, negative 7 is the top one, so I have to write that first. And then I'm going to say subtract 4. Now, why did I write subtract 4? Isn't 1 over 3 to the 4th the same as the inverse of 3 to the negative 4? Aren't those the same?
Yeah.
So I can rewrite this. I could say, oh, this is the same as 3 to the negative 7 plus a negative 4. Or I could just use my rules for integers. I could say, oh, this is the same as plus the opposite. Plus the opposite will still give me negative 7 plus a negative 4. So what will my answer be in this case? 3 to the negative what?
11.
Now another way I could have done that, you guys, is there's so many ways to do these, right? Okay, if you want to leave this 3 to the 4 here, another way I could have done this is I could rewrite this as 3 to the, I'm sorry, this is positive 3, to the negative 7, and then I had 3 to the 4. What you could have done is just simplified it initially. Well, I know that this 3 to the negative 7 is the same as 3 to the 7 here. And I still have the 3 to the 4 here. This way I don't have any negatives. Because sometimes they might ask you to give the answer with no negatives. Isn't this the same as 3 to the 7 plus 4 or 1 over 3 to 11? 1 over 3 to the 11 is the same as 3 to the negative 11. Those guys are the same. This inverse is the same as this. These are equivalent. This is written with a negative exponent and this is written without. Sometimes you will be asked to write your answer in simplified form without a negative exponent. So you would have to do the flip of any negative exponent. And like I said, you guys are going to have plenty of practice doing that today. So let's do some of the problems. Now, Curtis said he had trouble with, what you have trouble with, Curtis, you said?
The fractions.
The fractions? You understand it now? Okay. All right, so let's look at some problems though. All right, like number 1. Let's do one on number 1 here. These are pretty easy. What's the answer to the first problem? X over 4 divided by x over 4.
1.
It's going to be 1. You could write down the rule if you want to. Or you could just say 1, because we know that anything over itself is 1 as long as it's not 0. Okay, you guys can do the other two. The other two are real easy. I'm on page 3. Okay, B says, what must each of these quantities equal, assuming that none of the variables is 0? That answer should be what? Each one of these, the answer should be what? 1. All right. Number 2 says, simplify these other problems. So let's just do A. If I have A to the 125, remember I told you that's the same as putting 125 over 125. What's my answer? 1. So anything to the 0 power, I don't care what the base is going to be equal to 1. That includes this one with the variable. All right, so far everything's easy. Let's go to number 3. Consider the quotient. Now, what's another way to write this? Okay, we could also write that as x to the negative 3 if we were to simplify it. Because it's going to be a quotient problem, we would subtract the 2 minus the 5. That would give me x to the negative 3. And then if I want to write it with no negative, what would it look like? What's the inverse of that? 1x to the 3rd. Okay? That's the inverse of x to the negative 3. So, I just did that just to do it, but let's see what questions they want to ask. Number A says, write the quotient using the exponential law from exercise 1. Well, we did that. That's this part here. X to the 2 minus 5 equals x to the negative 3. We already did it when we did it. Then write it without a negative exponent. We already did that part too. You just write the inverse of x to the negative 3. Now on exercise 4, what do they want us to do?
Rewrite the expression and simply determine how to use a negative exponent.
Okay, so what would A be?
1 over 16.
Well, I'm going to write it as 1 and 4 over 2, just so you guys see where it comes from, which is 1 over 16. Okay? And they don't want any negative exponents whatsoever. So this one is just going to be 1 over x squared.
Yep.
What about C?
Then you can write it as 1 over
1 and 2 to the 3rd, which is the same as what?
1/8.
1/8. And then D?
1 over y to the 10th power.
Yeah, that's all you do. Now on the bottom, page 3, exercise 5A, this is negative, so the inverse would be x squared.
X squared.
What would B be?
Y to the 5th power.
Y to the 5th power. What would C have as an answer? X to the 3rd power, it looks like, yeah.
Miss B,
Yes,
how do you get one over here? This,
that was given to you. Which one are you talking about?
the C one.
This one?
Top.
Because this is a negative exponent, which means the inverse of 2 is 1 over 2. Because remember, if I have in fractions, if I have a whole number, the inverse of the whole number is 1 over that whole number, because I can write the whole number over 1 as an improper fraction. So the flip of it, or the inverse of it, is 1 over the whole number. Well, this just happens to be 2 to the negative 3. This means I need to take the inverse. Well, what is the inverse with a base of 2? What is the inverse if I put it over 1 like this, Min? That means that the 2 and the 3 go down here. And it's no longer negative on the bottom because I've taken the inverse. I've inverted it. So the 3 is not going to have a negative attached to it anymore. It's just going to have a 3. It's going to become positive exponent. Okay, so Mint, what would I do here? If this is negative down here, it needs to go up to be the inverse. And if this is negative here, it needs to go down to have the inverse, so I don't have any negatives in my exponent. So what should I have on top here?
Must be 1, right?
No, this is a -7, so what would the x be?
So where did the, oh, that's the bottom one. Oh, I see.
Yeah, I'm doing the you're doing which one? This one? Okay.
I see the, okay, I see what you,
So do you see that the x to the
Yeah.
-7 became positive 7x? And then what would I do with the y?
why is you move it down? Or
Move it down. And what's the exponent?
That's a 5 negative.
5. And,
That's
no,
a 5.
positive.
No, I positive. Because
Yeah, because
you
we're
flip it.
switching.
Okay.
Yeah, you're flipping or you're doing the inverse, okay? All right. Okay, so let's do some more practice here. On exercise 6, you need, this is something that you might see on the compass test. On exercise 6, I want you guys to take a minute and tell me what the simplified expression would be for exercise 6 once I flip everything that's negative. And remember, you only flip the negative ones. What would happen to this x -2 and this x -5?
So that you need to flip x5 is positive, right? Up.
x5 goes up, okay. What about x2, -2?
It's go down, right?
It goes down, okay. And then what about, well, the y is positive, but what about this y down here?
That's 3 going up.
Yeah, y to the 3 goes up. Now I got to do the other rules. I have x to the 5th and x to the 2nd, but they're being divided. This is being divided. So how do I figure that part out? That would be x to the 5 minus 2. Okay, which is x to the 3rd, and it's positive. And what's happening with the y's? The y is going to become what? They are right next to one another, so they're being multiplied, not divided, but they're being multiplied. So what happens to?
15, right?
No. This is not to a power.
Oh,
This is just a product. So if it's just a product, what do I do?
you add it?
Yeah. And how much would that be?
8.
8. So which one of these is right? Number 1, number 2, number 3, or number 4?
3.
Number 3. So see how we had to do our inverses, and then we had to do the other rules for division with the quotient and for the product. So you gotta sometimes do a rule within a rule to get the right answer. Okay, and if you've never done this before, it's gonna take a little practice. So don't beat yourself up, okay?
No, I never.
If you've never done it before, that's okay. Take your time. And because of Curtis's question and request, you have 2 tries at both the pre-test and post-test today.
Sorry.
No, they have 2 tries. They can take it or leave it.
I have to make a quick phone call.
Oh, okay. All right, my darlings, what's going to happen with 7A? We're going to put some real numbers to this. They want you to evaluate each of the following expressions using I'm sorry, I'm all the way down to 8. They want you to rewrite the following expressions without negative or 0 exponents. You can't have either one.
So then you put 1, right? 1 over, 1.
Yeah.
4 over 2.
4 squared.
4 square.
Yeah. And
So,
that's the
okay.
same as 1 over 16. So either one is okay. If you were to evaluate 4 squared, it would be 1 over 16. I think they don't really care. They just want to see you take care of the exponents okay. What would 4 to the 0 power be?
Not be 4.
What did I tell you to the 0 power means? Look at your rules. What does anything to the 0 power mean? Isn't that the same as 4 over 4? How much is that?
Oh, that's 16?
No, this one is 16. 1 over...
Yeah, I see that.
Okay. What's this one? Anything to the 0 power is equal to what? Honey, could you go to page 2 and look at the number 6? And it says anything to the 0 power
Oh,
is
that'd be
equal to...
1, huh?
Yeah. So that's one you need to remember.
Yeah,
Okay.
that'd be 1, okay.
All right. What about...
Oh, that'd be 1.
Okay. What about number C?
Well, see, the same thing as A anyway, right?
Yeah, but you got a negative. So it's negative 1
Oh, yeah, 4.
over 4
negative.
squared. So you don't forget the little negatives and stuff.
Negative.
And that's the same as negative 1 over 16. Okay?
Oh,
All right, I'll let you guys do the rest of those on your own. Number 8. What's great about this one is you're going to use substitution as your friend. They tell you that A is equal to negative 1, B is equal to 2, and C is equal to 3. So you're going to just plug those numbers in. So here, A is equal to negative 1, B is equal to 2, and C is equal to 3. So when I evaluate the inside, I'm going to get negative 2 to the 3rd power. How much is negative 2 to the 3rd power? That's negative 2 times negative 2 times negative 2. How much is that?
That's be 16, right? No, 2
2 times 2
4,
times 2. 8? What kind of 8?
Negative 8.
Okay. That's it. Plug in your numbers and you'll get all the answers there. Okay, let's do this fraction one here. Do I even need to do anything, man? Look at this 0 right here.
No.
So what's my answer?
It's just 1.
Just 1. So sometimes you want to look at the overall to make sure you're not doing unnecessary work.
So if there's a 0 anywhere, it's going to be a 1. Is that the rule?
No, if there's a 0 in your exponent.
Exponent, right.
Yeah.
Yeah.
But you're right. If I'm multiplying and I have a whole number 0, it's going to be 0, not 1.
Right, that's what I meant.
It'll be 0, not 1.
Okay.
Okay? So I think you guys need to kind of chew on this a little bit, and then if you are getting stuck on any of the other problems on the next couple of sections, let me know. Did you have any questions, Curtis, or you get it?
No, I'm good.
You're good with the study guide?
I just, I have to redo a few, but I just keep doing it.
And you got it?
And I got it. Yeah.
Okay. Nin, I want you to finish all of the problems up to page 4, and then let me see it. Let me make sure that you understand it
Okay.
before you start doing the actual practice problems, okay? And let me go over a couple with you if you have questions. Hi, are you okay?
I think I failed that one. I haven't touched it.
Well,
We
which
got
one
okay.
was that, from yesterday?
No, Friday. It's
From
first
Friday?
step.
Okay.
Not yet. I'm not done because I tried to listen to you. It's all right.
Oh, okay. Yeah, you can go ahead and finish if you want to. Did I give you 2 tries on that one?
I don't think so. It's too late.